Welcome to the ODE. We want to see how we can solve this. Y double prime plus 2y plus 6y is equal to exponential x. So this is an unilinear ODE with the constant coefficient. So first of all, we are going to consider the complementary part, which reduces to y double prime plus 2y single prime plus 6y is equal to 0. So to solve the complementary part, we are going to let our y to be equal to exponential mx. Then we differentiate y once to get m exponential mx, and we differentiate it again to get y double prime, which is equal to m squared exponential mx. Then we substitute the values here, so you have m squared plus 2m plus 6 exponential mx, which are factored out, is equal to 0. And exponential mx can never be equal to 0, which means that your m squared plus 2m plus 6 is equal to 0. So this is a quadratic equation whereby we are going to apply the quadratic formula, which tells us that m is equal to minus b plus or minus square root of b squared minus 4ac. You divide everything by 2a. And in our case, our a is equal to 1, our b is 2, and our c is 6. So we substitute the values here. So minus 2 plus or minus square root of 2 squared will give you 4 minus our a is 1 and our c is 6. So you have 1 times 2, 1 times 4, which is 4, times c, which is 6, 24. So this is minus 24 divided by our a is 1, 2 times 1 is 2. That way, which is equal to negative 2 plus or minus root of negative 20 over 2 over 2. This can be written as minus 2 plus or minus square root of negative 4 times 5 divided by 2. So square root of negative 4 will give you so m, I write it here, m is equal to square root of negative 4 will be plus or minus 2i root of 5 divided by 2, which simplifies to minus 1 plus or minus I root of 5. So our y complementary will be given by exponential negative x into bracket c1 sine of root of 5x plus c2 cos of root of 5x. You close the bracket. Now to obtain our yp, will be given by d squared plus 2d plus 6 everything. Y is equal to exponential 2x by the operator. Now, and using this fact, yp is equal to exponential rx over f of d, which is equal to exponential rx over f of r, whereby r is the constant on the exponent part. In our case, so we shall have our yp as equal to exponential 2x divided by d squared plus 2d plus 6, which is equal to exponential 2x divided by, instead of d, we substitute it with the 2. So you have 2 squared, since here it is d squared, plus 2 into bracket 2 plus 6. This is equal to exponential 2x into bracket 4 plus 6, which is equal to exponential 2x divided by 14, meaning that our yp is equal to 1 over 14 exponential 2x. So the solution, the general solution of our given OD, which was y double prime plus 2y single prime plus 6y is equal to exponential 2x. Our general solution will be given by y, which is equal to yc plus yp, which is equal to exponential negative x into bracket c1 sine of root of 5x plus c2 cos of root of 5x. You close the bracket plus 1/14 exponential 2x. In the other ones, our y is equal to exponential negative x into bracket c1 sine of square root of 5x plus c2 cos of square root of 5x. You close the bracket, then plus 1/14 exponential 2x. So that is our general solution of our given ODE. You can always test to see whether your working is correct by simply you get, maybe I can give you int, you get your y single prime, you differentiate this once. For example, if you differentiate this once, it will give you negative exponential, this is negative exponential that into bracket c1 sine of root of 5x plus c2 cos of root of 5x. You close the bracket. Then this is a product equation plus exponential negative x into bracket 5 c1 sine of root 5x minus 5 c2. This is cos, sorry, when you differentiate sine you don't get cos. So this is cos. The other one negative c2 sine of root 5x, you close the bracket. Then plus you differentiate this, which will give you 2/7, 2/14, sorry, exponential 2x. Then you differentiate this again to get y double prime as equal to exponential negative x into bracket c1 sine of root 5x plus c2 cos of root 5x. You close the bracket. Then you move on. You now differentiate whatever is inside the here. This part, which will give you exponential negative 5 exponential x, sorry, into bracket 5 c1 cos of root 5x plus minus, this is cos, when you differentiate it, it will give you minus 5 c2 sine of root of 5x. Then you come to this other part here, you differentiate it here, so you will have minus exponential negative x into bracket 5 c1 cos of root 5x minus 5 c2 sine of root 5x, that way. Then now you keep this constant, you differentiate this again, which will give you plus exponential 5x into bracket. When you differentiate this, it will give you negative 25 c1 sine of root of 5x minus 25 c2 cos of root 5x. You close the bracket, and then plus you differentiate this, which will give you 4/14 exponential 2x. Once you have obtained all this long equation, all this one, and this other part here, you come and substitute your given ODE, and when you do it correctly, you are going to realize that this working is correct. kindly try this. Substitute this long value. So you substitute all this, you plug in this long value here, all this on this equation, and see whether the right hand side will be equal to the left hand side, and let me know your outcome. Thanks so much for taking your time to study with me. For more such studies, kindly join me in my YouTube channel so that we may continue learning together. Bye bye. See you in the next video.